Hey everyone, today we are talking about something absolutely crucial: security in web applications. Whether you are a developer, a tech enthusiast, or just someone who wants to know how your data stays safe online, this is for you. Let's dive in. So, what exactly is security? Simply put, it's about protecting sensitive data and business logic in web applications. Think of it as an invisible shield that safeguards everything: your passwords, personal data, and even the app's internal logic. Without it, well, it's like leaving your house unlocked and hoping no one walks in. Now let's talk about the methods we use to protect applications. So here are the big ones. The firewalls. Imagine them as the security guards, keeping unwanted traffic out. HTTPS. This ensures the connection between your browser and the server is locked and secure. SSL TLS. Think of these as secret handshakes or for encrypted communication. And authentication. It's the process of proving you are who you say you are, like logging in with a username and a password. So, here is a quick question: do you use two factor authentication? It's one of the simplest ways to secure accounts. Let me know in the comments if you use it. Next, here is something important to know: security is a known functional requirement. That means it's not about adding flashy new features, it's about keeping the app safe and earning users' trust. And trust is everything, right? No one, no one is going to use an app they don't feel secure with. Here is another key point: security should be integrated right from the start of development. It's not something you slap on the last minute. Imagine you are baking a cake. You wouldn't forget the flour and add it later because it's baked, right? Same with the security. Build it in early. Finally, security is about mitigating risks. Whether it's a known vulnerability like SQL injection or phishing attempts, having solid security measures in place helps you stay one step ahead of attackers. So, why Spring Security? Let's start with the problem. Application security is no joke. Implementing it with the custom code or frameworks can be complex, time consuming, and let's face it, it's not very fun. So, how do we simplify this? So, here comes the Spring Security. Spring Security is built by the experts at Spring, designed to address all the common security scenarios. It's easy to set up and saves you from reinventing the wheel. Let's break down why it's a game changer. So here are the key benefits of Spring Security. It protects against common vulnerabilities like CSRF and CORS attacks. We will we will be learning those attacks in our later videos. It's constantly updated to address new security risks, and it simplifies securing your pages, API paths, enforcing rules, and even method level security. Spring Security supports multiple authentication standards, including username password authentication, JW tokens, OAuth 2 framework, and OpenOID Connect. So, whether you are building a simple app or a large scale application, Spring Security has you covered. So, why spending time building custom solutions when Spring Security can handle it all for you? With minimal configuration, you can ensure your app is secure and focus on building features your users love. Now look at some typical scenario in a Java web application. So before diving into that, we need to understand what are servlets and filters. So in Java web applications, a servlet container like an Apache Tomcat plays a vital role. So it acts as a translator, converting HTTP messages into objects that Java code can work with. For example, HTTP requests are transformed into servlet request objects and passed to servlet methods as parameters. Once the servlet processes the request, the output is sent back as a servlet response, which the container then packages into an HTTP response for the client. Now let's talk about filters. Filters are used to intercept requests and responses, allowing you to execute custom logic before the main application code runs. A common example is in the frameworks like Spring Security, where filters help enforce security by checking user permissions and access controls. Together, servlets and filters form the backbone of Java web applications, ensuring requests are handled efficiently and securely. So, have you ever wondered how Spring Security handles user authentication so seamlessly? So, let's take a deep dive into its internal flow and understand how all pieces fit together. So the journey starts with the Spring Security filters. These filters form a chain, intercepting every incoming request. So their main goal is to determine if authentication is required. If it is, the user is redirected to a login page, or otherwise their previously authenticated details are retrieved for further processing. Next up, we have the authentication filters. Like the username password authentication filter, this filter extracts user credentials like username and password from the HTTP request and prepares an authentication object. This object is the cornerstone of Spring Security, holding all the authenticated users' details. Now enters the authentication manager, a central player in the authentication flow. Once the filter passes the authentication object, the authentication manager delegates the validation of user details to one or more authentication providers. So there can be multiple authentication providers. So think of it as a conductor managing multiple providers to ensure every request is verified. The actual validation happens in the authentication providers. So it contains the logic to verify user details against the database or some other systems. So if the credentials check out, the processes moves forward. Here is where the user details or user details manager comes into play. These services handle fetching, creating, updating, or deleting user details in your database or storage systems. They are essential for maintaining accurate and up-to-date user records. But wait, plain text passwords are a no-go, right? So here comes the password encoder, a service interface that securely hashes and encodes passwords before storing them. This ensures user credentials remain safe, even if your database is compromised. Finally, once the user is authenticated, their authentication details are stored in a security context. This context is thread local, meaning it's specific to the current user session, ensuring secure handling of user information throughout the application lifecycle. And there you have it. From filters to the security context, Spring Security's internal flow ensures every request is authenticated and secure. If, if you want more deep dives like this, don't forget to like, subscribe, and hit the notification bell. Thanks for watching.